Welcome to today's session on project appraisal. We are going to first look at ways of making simple investments. The first one we're going to look at is simple and compound interest. You may want to invest some money now, and you expect that money to grow up to some amount, say within 1 year's time. An example we could use is where you put money in the bank and you expect to earn interest on the amount that you've deposited. You could earn interest in one of two ways, either as a simple interest or as a compound interest. Simple interest involves simply adding interest to an invested capital sum of money, whereby the interest that is added each period is added to the capital sum only and not to the interest earned in previous periods. So you invest, for example, 2,000 for 1 year, and you earn interest only on the 2,000 for that particular year. The formula for simple interest is future value equals present value, the present value being the amount that you're investing now, or the principal, open brackets 1 plus R being the rate of interest, and N being the number of periods over which you are making your investment. Compound instrument, on the other hand, is a system that adds interest each year to both the original capital plus any interest added to debt. So this is whereby you invest a principal. If it is compounded, say quarterly, after 1 quarter the principal earns interest, then the principal plus the interest earned is reinvested for another quarter. So in the second quarter the principal will earn interest as well as the interest will earn interest. The formula for compound interest is future value equals present value, which is the amount invested or the principal, open brackets 1 plus R, close brackets to the power N, N being the number of periods over which the interest is to be earned, and R being the rate of interest. Let's look at a simple example. In this lecture example, B invests 500 in a building society account, earning compound interest of 10% per annum. How much will the investment be worth in 5 years' time? So the principal 500, interest rate 10%. So after 1 year the principal is not withdrawn, instead the principal is reinvested up to a maximum period of 5 years. So you make that to the power 5. So the 500 compounded at 10%, in 5 years time it will be worth $805.20. compounding and discounting takes into account the time value of money. Time value of money simply means that an amount of money is worth much more today than, say, if it was going to be received a year or 2 years from now. This is because that amount of money which will be received a year or 2 years from now, the purchasing power would have been eroded due to inflation. There's also the uncertainty that you may not actually receive that amount of money 2 years from now because of the time factor. Anything could happen in between now and 2 years from now. There's also the opportunity to invest. If I received this 1,000 now, I could invest it so that it earns me some interest. Whereas if I have to wait for 2 years, then I would have lost out on the interest which I could have earned had I invested the 1,000 now. So that's a lost opportunity. So discounted cash flow is a technique that takes into account the timing of cash flows and allows comparisons between cash flows arising at different points of time, taking the 3 factors that we've discussed into account, being the inflation, the uncertainty, and the opportunity to invest. The present value is the value at time 0 of future cash flows, having taken account of the time value of money. We use this in investment appraisal, and it represents the maximum an investor will be willing to invest for a future cash inflow given a specified required return. With compounding, we move from a present value to a future value by adding compound interest each year. Whereas with discounting, it's a reversal of a compound. So we start at the future value and work back to bring that amount to the present. Another way that we could represent interest rate is by calculating an equivalent rate, also known as an effective annual interest rate. An effective annual interest rate is the corresponding annual rate when interest is compounded at intervals shorter than a year. So the non-annual compounding interest rate can be converted into an annual equivalent using the formula below. The formula being 1 plus R, the capital R being the effective annual rate, equals 1 plus small r, the small r being the period rate to the power n being the number of periods in a year. So when computing the effective annual rate, we make the effective annual rate, the big R, the subject to the formula by moving the 1 to the other side. So the formula becomes big R equals, open brackets, 1 plus small r, close brackets to the power n minus 1. The EAR is also called the APR, or annual percentage rate, by banks, building societies, and other credit companies. We look at another example We invest 300 at 2% monthly interest rate. We are required to calculate the value of the investment after a year. %2 monthly after a year it's actually 2 years, not 1 year. So the 300 being the principal, being invested at 2% monthly. So there are 12 months in a year, 24 months in 2 years, so to the power 24. This amount would equate to $482.53 after 2 years. We move to the B part of the question. What is the effective annual rate of interest? We substitute in the effective annual rate. So we make R the subject of the formula by moving the 1 the other side and substitute in our formula. R equals 1 plus 0.02 to the power 12 minus 1 to give us our effective annual rate of interest of 26.82%. We move to another kind of interest rate, the nominal rate. Sometimes the annual rate of interest is quoted as a nominal rate rather than an effective rate. For example, a credit card may have a 1% monthly interest rate. This may be quoted as a 12% annual rate. So the nominal rates should never be used as an annual rate. They should always be converted to an annual percentage rate. We illustrate that in an example. 1,000 is invested now at a nominal interest rate of 15%. Interest compounded monthly. How much has the investment grown up to at the end of the first year? So the nominal rate is 15%. So we change this to a monthly rate by dividing by 12, which gives us 15% divided by 12 months equals 1.25%. Therefore, the end of the first year, 12 compound periods, the investment will be worth 1,000 times 1.0125 to the power 12, which gives us $1,161. We proceed with discounted cash flows. Discounting is the opposite of compounding, as we earlier alluded. Discounted cash flow techniques take account of the time value of money. which is that money is worth much more now than in the future. So the same value, same amount, 1,000 is worth much more now than a year's time from now. The fact that money received now is worth more because it could be invested to become a greater sum at the end of a year. The present value so rather than calculating the terminal value of an investment here, we are calculating an equivalent value of money at an earlier point in time. So the present value is what that future value will be worth now. To calculate this, we rearrange the compounding formula, which becomes present value represented by SO, which is O for times 0 equals SN in the period in the future divided by open brackets 1 plus R being the cost of capital or the rate of return, close brackets to the power N, the N being the period in the future. We illustrate that in a question. We need 1,600 at the end of 5 years from now. Assuming we could earn 10% per annum, how much should we invest now? So we invest an amount now, and this amount 5 years from now at 10% should give us 1,610. So now being SO, 5 being the value in the future, which is 1,610, we divide that by the cost of capital of 1.1 to the power 5 to give us $1,000. So we need now at time 0 to invest $1,000 for 5 years at 10% for us to have a future value in 5 years time of 1,610. We continue with this video lecture in video 2.